Hello students, this is Hemal sir. We are now starting with oscillations. It's very important chapter. We are done with rotational dynamics, uniform circular motion. We have studied translational motion. We have studied projectile motion, submotion, different types of motion. Means when the particle moves, the different types that it's going to perform, the different ways in which it is going to move, we analyzed. Circumference of a circle पे particle घूमेगा, we call it as circular motion. When the body rotates, it is not going to change its position, but all particles will be performing circular motion. So a bit of complications we increased in the rotational motion. Now today we are starting with one most important chapter called oscillations. Oscillations, why did I say most important chapter? The reason is oscillations, or sometimes it's actually called oscillatory motion. So this is also a one kind of motion only. So I can say with this chapter, kinematics gets over. Oscillations, or it is also called oscillatory motion. Oscillatory motion को in a simple terms we call it as SHM. क्या लिखा मैंने? SHM. That is called simple harmonic motion. So oscillatory motion we are starting. Simple harmonic SHM. Very frequently you will see this SHM word. SHM we are starting simple harmonic motions, or we can say we are starting with the oscillations chapter. So this chapter requires a bit of more mathematics as compared to the other chapter. Of course, physics required maths, otherwise it's very difficult to understand. But in this chapter, few of more trigonometric identities are required. So jitna bhi required hai trigonometric identities, I'll keep making the list of it. I will even provide you with the all identities that you need to learn properly. ये chapter के MCQs में थोड़ा language भी it's very difficult sometimes to understand. So in this chapter, oscillations में, first we are starting with the very basic term called simple harmonic motion. Now what is simple harmonic motion? मतलब सबसे पहले word H is important, harmonic. Please try to understand. We are very much familiar with this word periodic motion. And this is oscillatory motion. Slight difference. I cannot say all periodic motions are oscillatory or all oscillatory motions are periodic. What do you mean by this? For example, tell me, if suppose you think about the, let's say, the minute hand of a clock, right? You talk about a minute hand of a clock. We started with the same example in rotational motion, if you remember, rotational dynamics. If you think about the minute hand, this is, let us say, the minute hand of a clock. It rotates clockwise, clockwise direction में rotate करेगा, in this direction. You think about one particle which is at the tip of, or maybe along this particular minute hand. So do you understand, when this particle, when this minute hand rotates, this particle is going to perform circular motion? Yes, वो circular motion perform करेगा. When it performs the circular motion, definitely after some regular interval of time, it is going to repeat its motion, isn't it? If I talk about minute hand, तो उसका time period कितना है? Means after what time it will repeat it, right? 60 minutes, 1 hour. So in this case, this minute hand will complete its one rotation after 60 minutes, after 1 hour. So can I say this particle is also performing circular motion with the same time period? मतलब it is performing UCM, वो uniform circular motion perform कर रहा. Speed is constant, that's why it is periodic. This is an example of periodic motion. I can give you a number of examples. This is, we are starting with this first. So what is periodic motion? The motion which repeats itself after some regular interval of time. The motion which repeats itself after some regular interval of time is called periodic motion. This is an example of periodic motion. Hello everyone. But this is not an example of oscillatory motion. एक simple सा comparison introduction में ले रहे हैं. We started with the introduction of this chapter called, alright, SHM or oscillations. Very frequently I will use this word SHM rather than oscillations, ठीक है? Because it is a simple harmonic motion. So I said this is an example of periodic motion where this particle is repeating its motion after some regular interval of time. But this is not an example of oscillatory motion. In a very simple words, how can I define oscillatory motion? Oscillatory motion I can call it as, in a very simple words, of course बाद में detail में properly I'll explain, it is a to and fro motion. In a simple terms you can call it as what? To and fro motion. To and fro motion of a particle along the same line, or you can say along the same path about the mean position. Means one particle will keep on, suppose if you take any one point as a reference point, that particle will always keep on crossing that reference point in either direction after some regular interval of time. In this case, अगर मैंने यही reference point माना, तो this particle is crossing this after regular interval of time. Every 1 hour के बाद ये position को cross करेगा. It is periodic. It isn't the to and fro motion. To and fro मतलब if I think about, I was talking about ये minute hand है, और suppose if I'm talking about this particular point. तो वो हमेशा ये point को एक ही direction में cross करता है. Do you understand? Clockwise direction में. It's not to and fro. To and fro मतलब ऐसा. I hope you understand. If means, it is crossing in one direction, after some time it is reversing its direction, and same position it is crossing in the other direction. So यहाँ पे direction तो change ही नहीं हो रहा है. When I talk about this particle of the minute hand, it is constantly going in one particular direction. It's not to and fro. आना जाना नहीं होता है, खाली जाना होता है. It is just crossing that position after some regular interval of time. So it is periodic. It is periodic motion, but it is not what? Oscillatory motion. Oscillatory motion meaning it is a to and fro motion. मतलब particle will constantly keep on crossing one particular position, जिसको मैंने reference position बोला, in either direction. So एक बार अगर ये suppose ये मेरा reference point है, तो particle ये direction में एक बार cross करेगा, and then after some time it is going to cross this position in the other direction, opposite direction. यहाँ पे direction तो change ही नहीं हो रहा है, एक ही direction में non stop this is particle is crossing. So this is just the example of periodic motion but not oscillatory motion. Let's talk about the motion of moon around earth. Is it periodic? Yes, you will say, because it takes some definite time. Motion of earth around sun, is it periodic? Yes, we will say, because it will keep on changing its it will keep on completing revolution after some regular interval of time. So these are all examples of periodic motion. But is this an example of oscillatory motion? No, right? Because this is not to and fro motion. When I say motion of the moon around the earth, वो एक same direction में revolve कर रहा है, circular motion perform कर रहा है. It is not going to cross, same position again and again in either direction. To and fro motion नहीं है. This is very simple terms में written. We have to define it properly exactly. यहाँ से अपना chapter begins. Alright, so these are the examples of periodic motion but not oscillatory motion. Now talk about this. Suppose if I have a very smooth depression, एक concave surface जैसा है मेरे पास, concave surface depression which is absolutely smooth, it's not rough. मान लो यहाँ पे one object, one small sphere, metallic sphere is being resting, उसको मैंने release किया तो obviously it is going to go in this particular direction, है ना? वो ऐसे मूव करें. बट यू अंडरस्टैंड, एज इट कम्स डाउन उसका पोटेंशियल एनर्जी काइनेटिक में कन्वर्ट हो रहा है, एंड एज इट गोज अप दैट काइनेटिक इज कन्वर्टिंग इनटू पोटेंशियल. सो इट कैन गो अप टू सर्टेन हाइट. आई होप यू अंडरस्टैंड. बट इट कैन नॉट गो इट कैन नॉट गो बियॉन्ड सर्टेन पॉइंट. जब तक एनर्जी कन्वर्जन होगा तब तक वो ऊपर जाएगा. देन अगेन इट विल कम बैक एंड विल क्रॉस दिस पोजीशन. आर यू अंडरस्टैंडिंग दिस पॉइंट? ये पोजीशन देखो जरा क्या हो रहा है. व्हेन यू रिलीज इट फ्रॉम हियर, it will cross it in one direction, and after reaching to maximum height it will again cross that same in the other direction. It is a kind of to and fro motion. ये to and fro motion हुआ ना, it's going and coming back. बैक एंड फोर्थ मोशन. टू एंड फ्रो मोशन इज व्हाट? बैक एंड फोर्थ मोशन. तो ये पोजीशन को कंटिन्यूअसली क्रॉस कर रहा है आफ्टर सम रेगुलर इंटरवल ऑफ टाइम. आफ्टर सम रेगुलर बोल रहा हूं बिकॉज ये सरफेस मैंने कैसा लिया है, इट इज एब्सोल्युटली द स्मूथ डिप्रेशन. When I say it is smooth, there is no friction. No friction, there is no loss of energy. There is no energy loss here. So can I say in this example, this is oscillatory motion? Yes, as well as periodic motion. Coming to a very important point. You can see in the two examples I've given in, I've written that it is periodic, but it is not oscillatory. This is an example where in this is periodic motion as well as this is oscillatory motion. Why did I say periodic? Because this surface is what absolutely smooth. अगर smooth नहीं होगा तो भी problem होगा. Suppose let's take an example of this. This is, let us say, vertical rigid surface, a wall you can imagine. There is a spring connected to this wall, means one end of the spring is attached over here and at the other end of the spring एक block connect किया मैंने. Clear है? मैंने एक block connect किया. This particular block, suppose if I stretch it, right? So spring gets stretched, spring gets elongated, and when you release that block, वो block को मैंने release किया, so do you understand? Spring will try to take that block back because of something called restoring force. Coming to that in detail, explain करता हूँ. So suppose if I assume that the surface is absolutely smooth surface. Surface कैसा है? Smooth surface. There is no friction. So there is no loss of energy. So when you stretch it and when you release it, it's going to perform what? Oscillatory motion. वो oscillatory motion perform करेगा because एक reference point को you can take it as what? Some mean position, or you can say maybe the reference position which will be crossed again and again by this body in the every after some regular interval of time it will cross it in the opposite direction. So it's going to be to and fro motion. It is going to be back and forth motion. So this block अगर मैंने माना, हाँ listen everyone, मैं कुछ बोल रहा हूँ, मैंने यहाँ पे लिखा कुछ तो mu is equal to 0. Mu is equal to 0 का मतलब what? There is no friction. So if I assume that there is no friction, then this is definitely an example of oscillatory motion as well as this can be an example of what? Periodic motion. But suppose if I say this mu is not equal to 0, अब बराबर सुनो, मतलब the surface on which that block is resting is not a smooth surface, it is a rough surface. तो क्या होगा? अगर surface rough है तो while oscillating there is some loss of energy. When I say loss of energy, मतलब this block is being, let us say, taken to this particular position, उसको release किया मैंने, release किया, it will come back and it will go in the other direction, but next time it will find that it will be going in the some up to some lesser distance because उसका कुछ energy loss हो रहा है, it cannot travel to the same distance, तो थोड़ा कम distance cover करेगा और थोड़ा next oscillation में कम करेगा, next और कम करेगा, धीरे धीरे block will come to what? Stop. मतलब this surface on which this block is resting, to which the spring is connected, if that surface is not smooth, so this will be only an example of oscillatory motion. वो oscillatory motion perform कर रहा है because it is to and fro motion or it is back and forth motion. But is it periodic? No, वो same time नहीं लेगा. The reason is because every one direction when it is moving, there is some loss of energy because there is a friction acting on it. So this can be an example of oscillatory motion with the rough surface, but not periodic. So try to understand my one point. All periodic motions are not oscillatory. All oscillatory motions I can say periodic provided there is no loss of energy, provided there is no, I can say, friction वगैरह नहीं होता. Friction होगा तो there is a loss of energy. So I repeat one very important statement. All periodic motion are not oscillatory motions. But all oscillatory motions, this is a very important statement with which we are starting in the introduction. All periodic motions are oscillatory motions, but all oscillatory motions need not be periodic. All oscillatory motions will be periodic provided there is no loss of energy. एक और example लेते हैं. For example, suppose अगर मैंने बोला simple pendulum, a very nice example. ये उसका mean position है और you can say equilibrium position है, where if it is At rest, it will always like to remain in this position because that's called equilibrium position. सारे forces balanced होते हैं. We will study in detail pendulum in this chapter. चालू हुआ है measurements. Now in this chapter we'll study it. Suppose यहाँ से if I release it, do you understand from here if it is being released, it will come to its mean position, but it will travel to this position on the other side, and then it will start. It will keep on oscillating. But when it oscillates, definitely ये oscillatory motion हुआ because over this, I mean, of course, this angle is very small. So this is crossing this position in either direction. To and fro motion हुआ. And if you remember, we had also defined the time period. ये सब derive करेंगे होगी ये chapter में. Was this the time period? T is equal to 2 pi root of L by G, where L stands for its length. तो ये time period define करना मतलब what? It is periodic. How is it periodic? So when the particle is being released from here and when it comes back, assume करो that there is here I have provided some source of energy जो constantly body को energy provide कर रहा है. If I do not provide, then it will be performing what? अगर मैंने यहाँ से release किया, it will go to this position and slowly, gradually, it will come to stop. That is called damped oscillations. Last part of the chapter. Right now we are not supposed damped oscillations में वो time period fixed नहीं रहेगा ना. So we are going to discuss this afterwards later on. So my assumption is that मैंने time period कैसे define किया? My assumption was that when this pendulum is oscillating, there is no loss of energy. तो periodic हुआ. So I repeat, all periodic motions are not oscillatory motions. But all oscillatory motions without any loss of energy, yes, definitely you can call it as what? Periodic motion. First thing. मैंने बोला full form. What is this SHM here again? What does this SHM stands for? SHM stands for simple harmonic motion. Simple harmonic motion. This chapter is very important. You can use these concepts of this chapter in electrostatics, magnetism, MEC. I can use these concepts everywhere in the, यहाँ से you will come to know about one very important term called phase of the particle. उससे मेरा wave optics can be cleared. मेरे EMI chapter में भी I will make use of this word called phase. So many chapters के साथ इसका connectivity है. So from the NEET and JEE point of view, definitely oscillations में से you can expect, at least from the NEET exam I can say 2 to 3 questions. JEE में भी this can be connected with many other chapters. तो ये चैप्टर की कॉम्प्लेक्सिटी धीरे धीरे बहुत बढ़ेगी. तो आई नीड यू ऑल टू प्रिपेयर दिस चैप्टर वेरी प्रॉपरली, विद द एकदम बेसिक्स क्लियर होना चाहिए. तो दैट्स व्हाट इंट्रोडक्शन में मैंने एकदम बेसिक्स से ही चालू किया. कम बैक टू दिस वर्ड सिंपल हार्मोनिक मोशन. क्वेश्चन कम सर आपने बोला सिंपल हार्मोनिक मोशन ऑसिलेटरी मोशन है और कुछ वर्ड्स ऐड करना है. टू एंड फ्रो ओनली इज नॉट इनफ. Simple harmonic में first of all I'm defining this, but before first of all try to understand the meaning of harmonic. Have you heard of harmonium? Harmonium वो म्यूजिकल इंस्ट्रूमेंट है. हारमोनियम, हार्मोनिक, हारमोनियम कहाँ से वर्ड आया? इफ यू सी दैट उसमें भी 7 सुर होते हैं ना, सा रे गा मा पा धा नी सा. इट रिपीट्स आफ्टर द 7th सुर. Every 8th one will be, now then it will be repeated. तो here also हार्मोनिक का सिंपल मतलब होता है what periodic. हार्मोनिक मोशन, forget about the simple, खाली हार्मोनिक मोशन का मतलब होता है it is that motion in which the particle, the one it is said to be, the body is said to be performing harmonic motion if with increase in time. देखो time कभी repeat नहीं होता. I have written time period as formula is 2 pi root of L by G for year. Suppose इसका आंसर आया 5 सेकेंड suppose. तो टाइम पीरियड 5 seconds, मतलब आफ्टर एवरी 5 seconds you will find that the motions are, some parameters are repeating. टाइम रिपीट नहीं हो रहा है, टाइम तो कॉन्स्टेंटली बढ़ रहा है. डेट आई मीन वीक मंथ, वो टाइम कभी रिपीट नहीं होता. तो दिस टाइम इज नॉट रिपीटिंग, बट आफ्टर एवरी 5 seconds, सपोज मैंने बोला 5 seconds, तो आफ्टर एवरी 5 seconds सर्टेन पैरामीटर्स आर रिपीटिंग. तो दिस कैन बी एग्जांपल ऑफ हार्मोनिक मोशन. तो हियर हार्मोनिक मोशन मतलब, हार्मोनिक मोशन मीनिंग इट इज द मोशन इन व्हिच द पार्टिकल with increase in time repeats certain parameters such as its displacement, its velocity and its acceleration. Kinematics, body की motion को analyze करना है तो there are 3 prime parameters, very important basic parameters: displacement, velocity, acceleration. तो harmonic motion matlab the particle which is performing harmonic motion will be repeating this parameter such as displacement, velocity and acceleration after some regular interval of time. So वो भी periodic होगा, time नहीं repeat हो रहा है, period after some regular interval of time, that is after some time period, these parameters are going to repeat. Now harmonic functions mathematics में if you see, they are sin theta and cos theta. मतलब if suppose I say theta is 0, तो sin 0 कितना होता है 0, cos 0 कितना होता है 1. When I say theta is 90 degree, sin 90 is 1, cos 90 is what 0. When I say 180 degree, तो sin 180 कितना होता है 0, cos 180, sin 180 is what 0, cos 180 is what -1. Then comes 270. Clear? So in this case, sine function 0, 1, 0, when you talk about this sine of 270 degree, so this will be going to be what? -1. And then if I take 360 degree, it will be 0. So 0, 1, 0, -1, 0, वो function की values देखो repeat हो रही. तो sine function is a harmonic function mathematically, because I said ये chapter का maths के साथ बहुत strong bonding है. So we need to understand very properly. Sine function is what? Harmonic function. Likewise, even cos function, the values will repeat over 1, 0, -1, then 0, then again 1. Alright? This will be again what? 1. This will be again what? 0. The values will repeat over. So sine function and cos functions are harmonic functions. What I mean to say कि ये chapter में displacement, velocity, acceleration के equations में sine cos functions आएंगे. Because sine function and cos function is what? Periodic function. They are the harmonic functions, and that's what I'm analyzing. Simple harmonic motion ही मैं analyze कर रहा हूँ. तो ये chapter में very frequently I will be defining all these equations. You will be finding it in terms of what? Either sine or cos. Tan theta नहीं होता, because tan function अगर मैंने लिया ना tan theta, then tan theta का value you know what varies from 0 to infinity. तो repeat नहीं होता. तो tan function is not a harmonic function. Sine cos. तो only basic things we need to know. You all know sin theta cos theta आ रहा है, तो sin theta का okay derivative basic terms से इसलिए I'm writing sin theta का derivative is what? Cos theta, है ना? And what is the derivative of सुनो बराबर, what is the derivative of sin 3 theta? तो it will be cos 3 theta. I hope you understand. But this 3 comes out because उसका भी मैं 3 theta का मैं अलग से derivative लेता हूँ. This is called composite function. So we take this 3 cos 3 theta we write. And derivative of sine is cos, and but derivative of cos is what? Minus sine. Derivative of cos theta will be what? Minus sine theta. This is what I want. That's it. अच्छा, एक one very important relation if you cannot remember these values, तो एक standard unit circle method है. PCM students can easily understand, otherwise मैं revise कर रहा हूँ, so nothing to worry. Suppose when you talk about एक circle, imagine करो एक circle whose you can say origin is so chosen that this origin lies along center of the circle lies at the origin. Center of the circle, मैंने एक circle ऐसा लिया है whose center lies at the origin. This is called standard circle. And suppose अगर मैंने imagine किया कि ये circle का radius is 1 unit, मतलब 1 centimeter, 1 meter जो भी ले लो, unit 1. That's called standard unit circle. I repeat, circle whose center lies at the origin is called standard circle. And circle whose origin lies at the center with the radius 1 unity, that's called standard unit circle. Tell me, बहुत simple है. Suppose if I take some point over here, or else suppose अगर इसका radius 1 है, this is my positive x axis, this is my positive y axis. Can you tell me इसके coordinates क्या रहेंगे? They will be equal to 1, 0. ये point के coordinates x axis पे. इसके coordinates क्या रहेंगे? Tell me. It will be 0, 1, isn't it? एक coordinate 0 है, y coordinate 1. Now ये negative x axis हुआ, तो ये point के coordinates क्या रहेंगे? -1, 0. और ये point के coordinates क्या रहेंगे? Tell me, x coordinate will be 0 and y coordinate will be what? -1. x coordinate 0 है ना, and y coordinate नीचे negative y axis है, तो it is -1. सब जगह पे 1 या -1 है. क्यों 1? Because this circle का radius is what? 1. Because this is which circle I'm talking about? Standard unit circle. Now tell me, suppose if I take some point over here, मैंने कोई तो भी एक point लिया P, and this is O. O is the origin as well as this is what? Center. Tell me, ये O और P को मैंने join किया, तो we know this value of OP. What is that? OP equals 1. Here, standard unit circle है, radius is 1. Suppose if I now take this angle as theta, ये angle मैंने theta लिया, बराबर सुनो, ये angle मैंने theta लिया, तो can I say ये point के coordinates क्या रहेंगे? Suppose मैंने यहाँ से if I draw a perpendicular, so can I say this right angle triangle में जो adjacent side है, will that become the x coordinate? ये x coordinate की value हुई है यहाँ से, and जो opposite side है this, will that become the y coordinate? तो ये point के coordinates क्या रहेंगे? r cos theta comma r sin theta. I hope you understand. x coordinate r cos theta है, r मतलब radius. What is the radius here? 1. What is the radius here? 1. तो can I replace this r by 1? 1 नहीं लिखूंगा तो भी चलेगा, but let me write it. 1 cos theta comma 1 sin theta. Simple meaning समझो मैं क्या बोल रहा हूँ. मतलब अगर ये एंगल थीटा 0 है, तो what is cos 0? I mean you can say ना, ये जो है मेरा वो cos 0 की वैल्यू है. अगर एंगल 0 ले लिया तो पॉइंट P will come here. तो अगर पॉइंट P इधर है, एंगल 0 है, पॉइंट P इधर है, तो उसका x कोऑर्डिनेट इज 1 एंड y कोऑर्डिनेट इज 0. उसका मतलब क्या हो गया? cos 0 is 1, sin 0 is 0. तो likewise this point P is somewhere lying here. तो ये मेरी 90 डिग्री की वैल्यूज हो गई, cos 90 sin 90, पहले cos बाद में sin. फिर अगर इधर है तो ये मेरी 180 की वैल्यूज हो गई. तो व्हाट इज cos ऑफ 180 minus 1 एंड व्हाट इज sin ऑफ 180? 0. अगर सपोज ये इतना एंगल सबटेंड हुआ, डू अंडरस्टैंड? इट्स लाइक दिस. अगर इतना एंगल सबटेंड हुआ, इज इट नथिंग बट 270 डिग्री, यहां से पूरा 3 quarters 270. So what are these values? It is for 270. What is cos 270? It is 0. But what is sin 270? It is minus 1. So this will help you standard unit circle for deriving, for defining the values of cos and sin function for some any odd angle. Yeah, 0, 90, 180, 270, 360 are some standard angles. So 120, 150, but you can easily understand कि ये मेरा 0 degree है line. This is corresponding to 90 degree. This corresponds to 180 degree and this corresponds to 270 degree and this also corresponds to 360. But we know the coordinates की signs. ये first quadrant में sign क्या होता है? Plus plus. Second quadrant में sign क्या होता है? Minus plus. Here the sign is what? Minus minus. Third quadrant में, and here it is what? Plus minus. So this will help you to get the values of any that particular function in terms of the standard unit circle. You can easily derive. A very basic introduction I have given, and now we are starting with this chapter, simple harmonic motion or oscillatory motions. Very important chapter, has connectivity with many other chapters. Okay, students. So after a very simple and a basic introduction about the oscillatory motion, the oscillations, simple harmonic motion, let's start with the actual definition and all concepts. Harmonic motion का meaning is now clear. The something in which the motion in which the particles will keep on repeating the certain parameters such as displacement, velocity, acceleration after some regular interval of time. So because sin theta and cos theta, they are the harmonic functions, right? We studied that how उसमें भी values repeat होता है. तो displacement, velocity, acceleration can be described, can be expressed in terms of sin cos. For which motion? SHM. What is the full form? Simple harmonic motion. We have not yet defined exact definition नहीं दिया है मैंने. Now I will give you the exact definition. Now please try to understand. Starting with the simple harmonic motion. ये motion को समझते हैं एक example लेके. Let's say that there is a spring, okay? Spring and it is kept on. This is absolutely smooth surface. There is no friction. मैंने starting में भी बोला that all periodic motions are not oscillatory. All oscillatory motions without any loss of energy. If there is no energy loss, then they are said to be what? Periodic. So I'm continuing with that. Suppose एक spring लिया है मैंने, alright? And spring के एक end पे one block is connected. एक block connect करके रखा है spring के साथ. Block is resting on the surface. Maybe example is very simple, but this will give you many concepts. Please बराबर से सुनना. So this block is resting on some surface which is absolutely smooth. Smooth मतलब there is no friction. अगर इसके ऊपर friction नहीं है तो कोई भी energy loss नहीं होगा when this body is going to move along this particular surface. This is moving along straight line. तो ये जो SHM है वो कौन से टाइप का SHM हुआ? आगे एक और वर्ड लगाना है, linear SHM. Let me write here only. We are right now starting with what? Linear SHM. कौन सा SHM? Linear SHM. Linear मतलब along straight line. Yes, because आगे जाके you'll have to study also something called angular SHM, right? जिसमें कुछ circular path या arc के along particle body will be moving. ये arc के along नहीं move करेगा. This body is going to move along this straight line. So this is linear SHM we are starting with. Definition पहले नहीं दे रहा हूँ. It's very difficult. I mean starting में definition देना मतलब वो ना खड़ी रट्टा मारना होगा. So let us first start with this. This block is connected to spring. This spring is neither being stretched nor being compressed. वो उसकी natural length है. Spring की ये क्या है? Natural length है. तो in that case block जहाँ पे है, this position is called what? Equilibrium position. इसको हम लोग क्या बोलेंगे? What is this position called? Equilibrium position. This is equilibrium position. I'm writing it here. Why is it called equilibrium position? Because this cannot start its motion on its own, or I can say all forces acting on this block are balanced. मतलब sigma f is equal to 0 है, ये उसकी equilibrium condition है, translational equilibrium. So this block is not going to move. Now at this particular position, so called equilibrium position, because on its own naturally spring का length natural length है, this block would like to remain at this position. That's why इसको मैंने equilibrium position बोला. Now suppose from this particular position मैंने ये block को है ना I displace this particular block से maybe towards right side. मैं ये block को right side लेके गया. Meaning what? Obviously the spring will get what? Stretched. Spring क्या हो जाएगा? Stretch होगा ना? You are trying to pull this block. You are trying to pull the spring, and spring को pull किया, stretch किया, this block will get displaced towards right side. So suppose now let us imagine that the spring is being stretched such that the block has been moved to this position. So now block मैं यहाँ तक लेके आया. कैसे? I said by stretching the spring. So when I stretch the spring, when the spring is being stretched, what am I trying to do? When the spring is being stretched, I am trying to relocate the molecules within the spring. You studied this concept in elasticity. That there is something called intermolecular force of attraction. Within the molecules, there is some force of attraction on account of, I mean, they will have some potential energy because of which this every molecule will, at least for the solid body, will try to remain at its position. And when you apply the force, when you try to, relocate them, by applying the force, I am trying to change the shape, I am trying to relocate them. So in that case, internally force generate hota hai. So we studied in elasticity that metal is more elastic than plastic because the restoring force hoga, it is more in metal. It is in terms of that we measure it. Okay, come back. Elasticity jaane do. Let's come to this point. When you displace this block over the smooth surface to this position, all right, एक position तक मैं लेके गया उसको. It's up to me. I can, within elastic limit for the spring, I can take it to any position. Suppose मैं यहाँ तक लेके गया. What I've tried here is that spring को मैंने stretch किया, मतलब within the spring जो molecules है, I've tried to relocate them. तो immediately molecules will always, because जब तक ये block को मैंने stretch करके रखा है, तब तक this spring will get stretched. As long as this block is being held at the same position, the spring remains in the stretched position. But as soon as you release it, ये block को मैंने छोड़ दिया, what will happen? The spring will try to regain its natural length. Because जो मैंने by stretching the spring, I have increased the distance between the molecules. So there is something called restoring force. I hope you understand. Restore. To restore मतलब to get the original conditions back. तो by stretching it, I've tried to relocate it the molecules. So when you release it, this restoring force की वजह से this spring would try to get its natural length in that ये block वो direction में move करेगा. वो मतलब किधर, this block अगर मैंने ये position से छोड़ दिया, this block will go in what direction? Left direction. वो move करेगा. So try to understand. This is the position. Let me call it as some extreme position जहां तक मैं लेके गया उसको. Extreme मतलब beyond that नहीं लेके जा रहा हूँ. Might be फिर spring permanently stretch हो जाएगा. Leave it, forget it. So tell me ये position पे जब भी when it is going from here to here, let me extend this line, the line of equilibrium position को मैं extend कर रहा हूँ, ठीक है? So do you understand when you are taking this block to that side, arrow देखो, ये x लिखा है. What is this x here? I will take this x as what throughout the chapter displacement. तो body का displacement किधर हो रहा है? Right में. Are you understanding? As long the moment you start moving it towards right, इसके ऊपर ये direction में force लग रहा है, and that force will try to help this block to move it to left, or else you can say this force will help the spring to get its natural length back. What is this force called? Fr. Fr stands for what? Restoring force. उसका मतलब कि जितना मैं stretching करते गया within elastic limit, उतना restoring force बढ़ते जाएगा. Internally, molecules, the other molecules will try to pull the molecules जो relocate हो रहे हैं, जिसकी position में change करने की try कर रहा हूँ. तो against the force which I am applying internally, because every molecules के आसपास एक particular region होगा जहाँ पे दूसरे molecules को पकड़ के रखता है. So in that field, it will try to pull it back. That is what I am calling it as potential energy है अंदर. So can you see one important point? ये जो restoring force, what is it? Fr again. Fr stands for what? Restoring force. Fr stands for what? Restoring force. Can I say this restoring force is proportional to displacement? जितना body का displacement ज़्यादा हुआ, उतना restoring force ज़्यादा लगेगा. अगर suppose if this block has been, if I would have moved it only to this position, तो proportionally stretching कम हुआ, तो restoring force would be lesser. So restoring force which is acting on the body here, you can understand it is proportional to the displacement. And can you see, look at this arrow please. Can I say अगर displacement body का right में हो रहा है, block if you move it to right side, restoring force is acting in the left direction because spring is getting stretched and will try to regain its original length by compressing it. So can I say this minus sign has a lots of significance here. Restoring force is proportional to displacement. In terms of magnitude, जितना displacement उतना restoring force लगेगा, and in terms of direction, it is exactly opposite to displacement. So there is a minus sign coming in the picture. Clear है? Let's move ahead. Tell me ये position पे जब भी block है, so called which position? What is this position called? Equilibrium position. What is this position? Can I say equilibrium position पे तभी body का displacement, block का displacement नहीं हुआ, ये तो natural length है. तो can I say number one, first thing, there is no displacement here. That is called x is equal to 0. X मतलब, what is x here? X मतलब displacement. I repeat, what is x here? X मतलब displacement. So what is the displacement here? 0. But here, this is the maximum displacement. Let us say block को मैं उसके आगे नहीं लेके जा सकता because maybe in that case I might cross the elastic limit of the spring, तो फिर वो permanently stretch हो सकता है. Leave it. Can I say maximum position है from the mean, from the equilibrium position, आगे जाके मैं उसको और एक नाम दूंगा. What will I call it as? Mean position. Mean. Pendulum का motion जो होता है vertical plane में उसका, this is the mean position where all forces are balanced. So this is mean position or also called what? Equilibrium position. So at mean position x is equal to 0. Mean position से maximum displacement हुआ, we call it as an amplitude. याद करो waves में. The maximum displacement, if suppose the particles are oscillating like this, तो from its mean position maximum कितना दूर जा रहा है? इधर ऊपर और नीचे, either upwards or in the downward direction. That maximum displacement you call it as what? An amplitude. तो ये amplitude हो गया. ये कौन सी position है मेरी? This is the right side में extreme position है ना? Right side में extreme position है, तो we call it as what? Right extreme position. ये mean position है. You call this position as what? Right extreme लिख रहा हूँ मैं. RE. RE stands for what? Right extreme position. जहाँ पे do you all agree that this x will be equal to plus a? A मतलब amplitude. What does this A stands for? Amplitude. What is an amplitude? The maximum displacement of the particle from its mean position in either direction. It's called amplitude. मतलब वो direction में भी amplitude होगा. Mark करते बाद. I repeat, the maximum displacement of the particle from its mean position in either direction is called an amplitude. तो यहाँ से maximum displacement body का होगा, उसको मैंने amplitude नाम दिया. Let's represent that amplitude by A. Plus लिखा because that's towards right side. मैं convention मान रहा हूँ यार. Usually we take right side cut, conventionally we take it as what? Positive, and left to the origin, मतलब we take it as negative. तो ये मेरा origin जैसा हो गया, reference line, mean position. तो right side का मैंने plus A लिया. Am I right? अगर मैंने बोला कि restoring force, that's very important characteristic equation, or rather let me write one more next step. Tell me, when I say Fr is proportional to minus x, does that mean Fr is equals to minus एक constant introduce करना पड़ेगा? That constant we call it as what? K. This is the characteristic equation of simple harmonic motion. Or let me write linear simple harmonic motion, because ये straight line पे, along the straight line this body is moving. That's why it is called linear SHM. So I repeat, restoring force is equal to minus kx. ये k मैंने constant introduce किया. This is called spring constant, or sometimes it is also called force constant, that depends on the material of this particular spring. Spring की material पे depend करेगा. It also depends on the stiffness of the material of the spring. मैं मेरा ball pen में भी एक refill use करता हूँ. That refill का stiffness, and there is also one spring used in truck or vehicles, very heavy vehicles. तो उसमें भी spring होता है. दोनों का stiffness is not same. I hope you understand. So for both the springs, the corresponding something called K will be different. Spring altogether a different lecture I will take spring के ऊपर. तभी वापस ये point पे हम लोग आएंगे. तो this is the constant. Fr is equal to minus kx. Fr is equal to minus kx. Fr is equal to minus kx is the characteristic equation. Please remember, this is the most important equation. अगर मुझे कोई motion समझना है कि SHM है कि नहीं, if I want to decide, if I can prove that Fr force acting there is equal to minus kx, it is SHM. But if it is opposite to displacement, it is proportional to displacement. ये equation. So I am coming to the definition. Let's first again come back to this. तो यहाँ पे there is no displacement. Do you understand? अगर displacement नहीं है body का, तो उसके ऊपर कोई restoring force नहीं act करेगा. Similarly, your displacement is maximum, तो can I say Fr restoring force will be maximum here. What will be that? X is equal to क्या है? A ना? तो will it be equal to minus Ka? Restoring force will be maximum. It will be maximum. And will it be equal to minus Ka? Minus n क्या indicate कर रहा है? It is acting towards left direction. और left side का अपना conventions क्या होता है? Negative लेते हैं. Are you understanding the conventions part very properly? Right? Please pay attention. Next. अच्छा. Do you understand? This force is equals to mass into acceleration. मान लो ये जो block मैंने लिया उसका mass is m. अगर block का mass m है, तो restoring force will be equal to mass into acceleration. So now, can I say therefore ma, restoring force was minus kx na, but now restoring force is by Newton's law, we know it is equal to m into a. So can I say it is equal to minus k into x? उसका मतलब acceleration, okay, acceleration is minus k by m into x. अभी k भी constant है, mass भी constant रहेगा, तो I can also say acceleration is also proportional to minus of x. मैंने start कहाँ से किया था? Force से चालू किया था, and I am ending at what? Acceleration. But you can see the same relation. Restoring force is also proportional to displacement, and it is in the opposite direction. Minus sign. Acceleration is also proportional to displacement, and it is in the opposite direction. ये only and only simple harmonic motion में होता है. It is not possible in other types of motion. Circular motion में, rest everywhere, you don't see this relation. इसीलिए मैं आता हूँ definition पे. It will make you, it will give you a clear definition of this linear simple harmonic motion. This analysis will explain you the clear definition of linear simple harmonic motion. But tell me, अगर force नहीं है, तो can I say acceleration भी नहीं होगा? So true, very true. F is equal to m में force नहीं तो acceleration भी नहीं होगा. और यहाँ पे force कैसा है? Maximum. तो can I say acceleration will also be maximum? चलो अभी values नहीं लिखते, अभी खाली maximum minimum लिखता हूँ. So do you understand? Even the force will be maximum, acceleration भी maximum होगा. राइट एक्सट्रीम पोजीशन पे. Okay, tell me. Now when you take this block to this side and if you release it, do you understand? यहाँ से मैं छोड़ रहा हूँ, यहाँ से I'm releasing it. यहाँ से रिलीज करना मतलब उसका वेलोसिटी कितना होगा? जीरो होगा. और here it's not going आगे ना, मैंने वहां से रिलीज किया. इसे रिलीज करना मतलब वेलोसिटी विल बी व्हाट? जीरो. टेल मी, व्हेन यू रिलीज इट फ्रॉम हियर, because of the restoring force acting on it, it will have some acceleration. Because of acceleration, when I say body accelerates, can I say velocity will increase? Yes. So as the body is being released from which position? What is this position called? RE matlab what? Right extreme position. What does this RE stands for? Right extreme position. जहाँ पे displacement कितना है? Positive A plus A, positive amplitude है. So when you release that block from here, it has no speed, but if it is released, because उसके ऊपर एक restoring force act कर रहा है, which will take that help, which will help that block to go to mean position. Force की वजह से acceleration होगा, and when I say acceleration होगा, can I say velocity will increase? Yes. So when you release this block from here, it will keep on moving with the increasing velocity, and it will come to mean position. So वापस जब ये आएगा, तो can I say वापस जब ये आएगा from the extreme position to the mean position, तब भी can I say velocity will be maximum there? Yes, because when it comes from here to here, तभी velocity क्या रहेगा? Maximum. Question comes, आगे जाके maximum क्यों नहीं होगा? Because when it comes from here to here, displacement वापस zero हो गया ना, there is no force. So in that case, when it comes from here to here, ये position पे velocity maximum होगा, but at the extreme position velocity क्या रहता है? Zero. Try to recollect, वापस pendulum पे आ जाओ. Suppose if this is a simple pendulum, if I release it from here, I said if I release it from here, मैं यहाँ से release नहीं कर सकता, यहाँ से release करो, क्या होगा? ये mean position था, यहाँ से release करो, क्या होगा? अरे उधर ही पड़ा रहेगा यार. But if you suppose it is being taken to this position and from there if it is being released, अगर मैंने यहाँ से release किया, so while coming back to its mean position, it will have what? Maximum velocity. So at the extreme position, velocity is zero hai, but at the mean position, velocity maximum. I'm just writing few parameters: displacement, velocity, acceleration, force. But connection किसका है? Displacement के बाद मैंने force लिखा, उसके बाद acceleration, बाद में I'm writing velocity. Okay. Now this block has certain mass, na? Every body on account of mass has what? Every body on account of mass possesses what? Inertia. Inertia of rest, inertia of motion, and also body resists, opposes any change in the direction also during the motion. So when I say this block is being released, यहाँ से release किया, it is going to go towards the mean position. Am I clear? It is going to go towards the mean position. When the body goes towards the mean position, okay? When the body goes towards the mean position, do you understand? यहाँ पे आके उसका velocity maximum है, but because it is moving, it has certain kinetic energy. So what is that kinetic energy over here? Speed maximum है तो कहना है kinetic energy भी maximum होगा at the mean position. Because speed is maximum, तो kinetic energy भी maximum होगा. Am I clear? So when I say when the block is being released from here and when it comes back to this mean position, it has maximum speed, it has maximum kinetic energy. Means it is moving, it is in motion. So because of inertia of motion, it will not stop immediately there. मतलब मैं यहाँ से इधर लेके गया छोड़ दिया, इधर आके रुकेगा नहीं. Because while coming back from extreme position to mean position, it has kinetic energy, it has speed, it has motion. So on account of that motion, inertia of motion will not stop there, but will continue its motion. वो अपनी motion को continue करने की try करेगा. In doing so, when it continues the motion, do you understand क्या होगा? The spring slightly gets compressed. और ये ब्लॉक समझो इधर तक आया. It comes to this particular position. I hope you understand. This is called right extreme position. Then this is called what? Left extreme position. And we all know this is called what? Mean position. Right extreme position पे मेरा displacement मैंने कितना लिया? Plus है. तो लेफ्ट एक्सट्रीम पोजीशन पे डिस्प्लेसमेंट बॉडी का कितना लूंगा मैं? माइनस है. दिस इज आल्सो गोइंग टू बी एम्पलीट्यूड. ट्राई टू अंडरस्टैंड. एम्पलीट्यूड इज द मैक्सिमम डिस्प्लेसमेंट इन ऑफ द पार्टिकल परफॉर्मिंग ऑसिलेटरी मोशन फ्रॉम द मीन पोजीशन इन ईदर डायरेक्शन. मैक्सिमम डिस्प्लेसमेंट इन ईदर डायरेक्शन. तो यहां से आई सेड अगेन कम बैक, व्हेन इट इज बीइंग रिलीज्ड because of its motion, it has some energy, will not stop here, will continue its motion in the same direction और एक position तक जाएगा where the spring gets compressed to the maximum limit. मैक्सिमम लिमिट तक कॉम्प्रेस हुआ, उसके बियॉन्ड कॉम्प्रेशन नहीं होगा। भाई वो किसके ऊपर डिपेंड करेगा, कितना डिस्टेंस तक आई हैड स्ट्रेच दिस पर्टिकुलर स्प्रिंग, मतलब ये ब्लॉक को मैं कितना पोजीशन तक लेके गया था फ्रॉम दिस मीन पोजीशन, उतनी डिस्टेंस पे उधर जाएगा, बिकॉज द सरफेस इज वॉट एब्सोल्युटली स्मूथ, तो देयर इज नो लॉस ऑफ एनर्जी, मतलब कॉन्स्टेंटली एनर्जी कन्वर्जन इज टेकिंग प्लेस। ट्राई टू अंडरस्टैंड नाउ, व्हेन एनी ऑब्जेक्ट इज बीइंग थ्रोन अप, व्हेन यू आर थ्रोइंग इट अप, एज इट गोज अप उसकी पोटेंशियल एनर्जी बढ़ रही है, बट उसका स्पीड कम हो रहा है, तो काइनेटिक एनर्जी विल डिक्रीज, बिकॉज देयर इज अ ग्रेविटेशनल फोर्स एक्टिंग। कैन आई से ग्रेविटेशनल फोर्स अपोज कर रहा है मोशन को, बट व्हेन इट कम्स डाउन ग्रेविटेशनल फोर्स उसको हेल्प कर रहा है टू गो डाउन, तो इन दैट केस उसका स्पीड क्या होते जाएगा, बढ़ते जाएगा व्हेन इट गोज डाउन, बट पोटेंशियल एनर्जी विल कीप ऑन डिक्रीजिंग, काइनेटिक एनर्जी विल कीप ऑन इंक्रीजिंग। एक्जैक्टली सिमिलर, देखो क्या हो रहा है, व्हेन यू रिलीज दिस ब्लॉक फ्रॉम हियर, एज इट कम्स टू द मीन पोजीशन, उसकी पोटेंशियल एनर्जी जो है राइट वो कम होती जा रही है, एंड इट इज गेटिंग कन्वर्टेड इनटू काइनेटिक एनर्जी, बट व्हेन इट कम्स हियर कंप्लीट एनर्जी कन्वर्जन नहीं हुआ, तो विल गो फर्दर, एंड फाइनली व्हेन इट कम्स ओवर हियर, व्हाट इज दैट पोजीशन कॉल्ड, एली, एली स्टैंड्स फॉर व्हाट, लेफ्ट एक्सट्रीम, यहाँ पे उसकी जितनी काइनेटिक एनर्जी थी वो सारी किस में कन्वर्ट हो गई, पोटेंशियल में, मतलब यहाँ पे वापस इट विल कम टू व्हाट, स्टॉप, यहाँ पे वापस स्टॉप हुआ, मतलब स्पीड विल बिकम व्हाट, जीरो, स्पीड विल बिकम जीरो, मतलब क्या जीरो हो जाएगा उसका, I'm not writing these parameters over here. Left extreme पे भी same parameter, extreme position पे same parameters होंगे. Once again उसके I can say kinetic energy इधर भी zero हो जाएगा. It will stop and again tell me अगर वो ये direction में जा रहा है from here to this direction, ये direction में जब displacement हो रहा है, क्यों आगे जा रहा है, क्यों stop नहीं हुआ, because of inertia. It has some inertia. So when it goes आगे, can I say I mean towards left side, can I say restoring force ये direction में लगेगा. So this is very important part of this chapter, of this definition, SHM. This is the characteristic equation of this chapter. Fr is equal to minus kx. I'll always start with that. Fr is equal to minus kx, where k is the force constant. So here, when the displacement is taking place in the left direction, all right, restoring force is acting in the right direction. ये मेरी definition clear करेगा. Let me conclude with one more last parameter. I've written displacement, restoring force, acceleration, velocity, kinetic energy, which is different parameters. And one more is what, potential energy, जो कि extreme position पे maximum होगा, and there is no potential energy here at the mean position. So mean position पे potential energy zero है, kinetic energy maximum है, whereas at the extreme position either right side or towards the left side, I can say kinetic energy zero है, but potential energy is what, maximum. So with this we can now define linear SHM. Linear simple harmonic motion is defined as the motion in which particle moves along the same straight line. देखो जब भी particle is being taken to the right extreme, it is going along this line, and when it is being released, it is coming along the same straight line towards mean position. तो मैंने ऐसा नहीं किया कि पार्टिकल आ रहा है ये, है ना, इट्स बीइंग टेकन टू राइट साइड एंड ओवर दिस पाथ एंड देन इट इज बीइंग रिलीज्ड, इट इज गोइंग अलोंग दिस पर्टिकुलर पाथ, ऐसा नहीं हो रहा है. Try to understand, it is along the same straight line, same path, over the same path, over the same path, path same है, over which the body is moving. So linear simple harmonic motion is the motion in which body is moving to and fro about the mean position, to and fro about the mean position between the extreme position. देखो कभी body extreme position को cross नहीं करेंगे. To and fro motion of the particle, body, object, मैं कुछ भी बोलूँ सब same है. To and fro motion of the particle about the mean position, mean or equilibrium, about the mean position between the extreme positions along the same straight line, about the mean position between the extreme positions along the same straight line, such that the force acting on the particle is always proportional to the displacement, and the force is always in a direction opposite to displacement. ये दोनों important point है. Magnitude of the restoring force is proportional to displacement, and the direction of the restoring force is opposite to displacement. And can I say जो मैंने force के लिए बोला वही acceleration के लिए भी applicable है. Am I right? Because A is also proportional to x magnitude wise, and direction wise it is what, opposite. So linear simple harmonic, let us define linear simple harmonic motion is defined as the motion in which particle moves, in which the to and fro motion of the particle about the mean position, between the extreme positions, along the same straight line, such that the restoring force acting on the particle is proportional to displacement and it is opposite to displacement. That's the linear simple harmonic motion, and these are very important features. क्या क्या लिखा है मैंने? X restoring force, acceleration, velocity, kinetic energy, and what? Potential energy. These are very important features, and this is the very important characteristic equation about the linear simple harmonic motion. Now, when you want to analyze linear simple harmonic motion, please try to understand one thing. ये फुल फॉर्म लिखना बहुत जरूरी है. वन वेरी इंटरेस्टिंग पॉइंट. हाँ, बराबर सुनो. सिंपल हार्मोनिक मोशन है, HM मतलब हार्मोनिक मोशन. सिंपल हार्मोनिक मोशन. Please remember, this is not, even though the name of the chapter is simple harmonic motion, ये according to me ये simple नहीं है. This is complex motion. क्यों? खाली नाम है simple harmonic motion. Pendulum भी बोलते हैं simple pendulum, वो simple नहीं है. In this chapter we will analyze. This is called simple harmonic motion, but I said analysis will become very critical. A chapter analysis is very critical. Why not simple? Because you can see every position पे while moving, मीन से राइट एक्सट्रीम से वापस मीन से लेफ्ट एक्सट्रीम, ड्यूरिंग इट्स पाथ. ये इसको क्या बोल रहे हैं हम लोग? बिटवीन लेफ्ट एक्सट्रीम टू राइट एक्सट्रीम का जो पाथ उसको हम लोग क्या बोल रहे हैं? पाथ लेंथ. आई मीन ओवर दैट पाथ इट इज मूविंग. यू नो व्हाट, एवरी पोजीशन पे देखो, कोई भी पोजीशन पे डिस्प्लेसमेंट सेम नहीं है. कैन यू सी, ये ए है तो ये माइनस ए ले रहा हूं. जस्ट डायरेक्शन भी क्लियर करना है, बिकॉज दैट इज टू एंड फ्रो मोशन, बैक एंड फोर्थ मोशन. सो एवरी पोजीशन पे डिस्प्लेसमेंट अलग. एवरी यू कैन सी वेलोसिटी यहां पे मैक्सिमम है, यहां पे और यहां पे जीरो होता है. एवरी पोजीशन पे वेलोसिटी इज अलग, एवरी पोजीशन पे एक्सेलरेशन इज अलग. मैं कोई भी मूविंग बॉडी को एनालाइज कैसे करता हूं, उसकी मोशन को? वी एनालाइज इन टर्म्स ऑफ व्हाट पैरामीटर्स? डिस्प्लेसमेंट, वेलोसिटी एंड एक्सेलरेशन. All three parameters, displacement, velocity, acceleration of a particle performing linear SHM is different at different points. हर एक पोजीशन पे हर एक पैरामीटर अलग अलग है. डिस्प्लेसमेंट अलग, वेलोसिटी अलग अलग, एक्सेलरेशन अलग अलग. तो यार ये सिंपल कहाँ हुआ? दिस इज नॉट सिंपल हार्मोनिक मोशन. एवरी पॉइंट पे सारे पैरामीटर्स चेंज हो रहे हैं. सो आई नीड टू डिस्क्राइब देम वेरी प्रॉपरली. एंड आई टोल्ड यू स्टार्टिंग में, बिगिनिंग में, हार्मोनिक का मतलब होता है पीरियोडिक. तो आई कैन एक्सप्रेस दिस डिस्प्लेसमेंट, वेलोसिटी, एक्सेलरेशन इन टर्म्स ऑफ व्हाट? साइन एंड कॉस फंक्शंस. सो थोड़ा सा कॉम्प्लिकेशंस आता है. Trigonometry part is, lots of trigonometry is involved in this. But before that, introduction के बाद ये जो basic lecture है उसमें one more last point. So now let's again conclude a very simple thing. I just want to tell you. Suppose ये mean position है. Now this is x is equals to plus a. आपको समझना है, whenever I say plus a, it is right extreme. This is mean. I will not write always equilibrium. This is equilibrium position, mean position, and this is left extreme position. लेफ्ट एक्सट्रीम पोजीशन पे हम लोग डिस्प्लेसमेंट कितना लेते हैं? माइनस ए. नो मैटर्स फ्रॉम वेयर द पार्टिकल स्टार्ट. सपोज मैंने यहां से रिलीज किया. इफ आई रिलीज बॉडी फ्रॉम हियर, डू यू अंडरस्टैंड, विल गो इन दिस डायरेक्शन. बिकॉज ऑफ इनर्शिया स्टॉप नहीं होगा, थोड़ा और आगे जाएगा. एंड देन फ्रॉम हियर आल्सो अगेन इट विल नॉट स्टॉप, बिकॉज यहाँ पे उसके पास क्या है? मैक्सिमम पोटेंशियल एनर्जी. काइनेटिक एनर्जी जीरो हो गया, इट स्टॉप्स ना. तो अगेन पोटेंशियलिटी किस में कन्वर्ट होगा? काइनेटिक एनर्जी में. एंड देन इट विल कीप ऑन ऑसिलेटिंग लाइक दिस. ऐसा क्यों हो रहा है? बिकॉज सरफेस कैसा लिया मैंने? स्मूथ. देयर इज नो फ्रिक्शन. फ्रिक्शन नहीं है, लॉस ऑफ एनर्जी नहीं है, इसीलिए आई कैन से दैट दिस ऑसिलेटरी मोशन इज पीरियोडिक मोशन. ऑल ऑसिलेटिंग मोशंस आर नॉट पीरियोडिक. अगर सरफेस रफ होता तो वो पीरियोडिक नहीं होता, मतलब वो ऑसिलेट करके धीरे धीरे इट वुड हैव कम टू स्टॉप एट द इक्विलिब्रियम पोजीशन, मीन पोजीशन. दैट इज डैम्प्ड ऑसिलेशन. फाइन. कम बैक. तो ऐसे अगर यहां से स्टार्ट किया, किधर से भी स्टार्ट करो, सपोज इफ आई स्टार्ट फ्रॉम हियर, यहां से स्टार्ट किया, इट गोज टू दिस पोजीशन. ओके, स्टार्टिंग फ्रॉम राइट एक्सट्रीम पोजीशन, व्हेन द बॉडी गोज टू दिस पोजीशन, उसका कितना डिस्टेंस कवर किया? व्हाट इज दिस कॉल्ड? एम्पलीट्यूड ए. ये भी ए है, माइनस ए तो खाली कन्वेंशन के लिए लिखते हैं. तो आई सेड फ्रॉम हियर टू हियर उसका डिस्टेंस कितना कवर किया? 2a. डिस्प्लेसमेंट कितना हुआ? 2a. बिकॉज वाइल गोइंग फ्रॉम राइट एक्सट्रीम टू लेफ्ट एक्सट्रीम उसका डायरेक्शन चेंज नहीं हुआ. एज लॉन्ग एज डायरेक्शन ऑफ मोशन डज नॉट चेंज, डिस्टेंस एंड डिस्प्लेसमेंट विल बी सेम. आई रिपीट. तो वाइल गोइंग फ्रॉम राइट एक्सट्रीम टू लेफ्ट एक्सट्रीम डिस्टेंस कवर्ड इज 2a, डिस्प्लेसमेंट इज आल्सो 2a. अभी यहाँ पे स्टॉप तो नहीं होगा बॉडी. I mean, it will stop for a while and it is going to change the direction. It will stop for a while and it is going to change the direction. अगर ये ऑब्जेक्ट को भी मैंने ऊपर फेंका तो when it goes to the maximum height, मतलब it has maximum potential energy, just for a while it will stop and it will change the direction. Right now? तो वही हो रहा है. जब भी मैंने यहाँ से रिलीज किया बॉडी को, it will go to that position and will change the direction and will again go back to this. तो ये एक टू एंड फ्रो मोशन हुआ. वन टू एंड फ्रो मोशन is called one oscillation. इसको हम लोग एक oscillation बोलेंगे. This is called one oscillation. Please try to understand. कहां से भी start करो, from any position you start, when the body comes back to the same position, that is one to and fro motion, one back and forth motion. What is that called? One oscillation. When जब भी particle यहां से start करके it goes to this and when it comes back, उसका displacement कितना हुआ? सोच के बोलो. Sorry, displacement is 0. Because जब start यहाँ से किया, goes to this and again comes back, तो अपनी original position पे आया ना, तो displacement 0 हो गया. But distance and displacement will be different because इसके बाद तो direction change हुआ. When the direction changes, distance and displacement cannot be same. Now tell me, what is the distance covered? इधर से इधर गया तो कितना distance cover किया? 2a. जब वापस यहाँ से यहाँ आया तो distance कितना? Distance is a scalar quantity यार, actual path length. तो कितना distance cover किया? 2a plus 2a. What is that? 4a. So when the particle completes one SHM, one oscillation, displacement would be 0 after every one oscillation, but distance covered will be what? 4a. And last point, there is something called path length. क्या बोलते हैं? Path length. यहाँ से यहाँ. Are this to the extreme positions, the extremities, the boundaries beyond which particle will not go? तो यहां से लेके यहां तक का जो टोटल डिस्टेंस है उसको हम लोग क्या बोलते हैं? पाथ लेंथ. तो व्हाट इज अ पाथ लेंथ? इक्वल्स 2a. डिस्प्लेसमेंट 0, डिस्टेंस कवर्ड 4a, एंड व्हाट इज अ पाथ लेंथ? इक्वल्स 2a. यू अंडरस्टैंड? पाथ लेंथ इज व्हाट? 2a from right extreme to left extreme. This is a very simple thing we have discussed here. Now we are starting with some analysis of this SHM. हमने यहाँ पे खाली SHM को define किया है. I'm now starting with the analysis. So please be very clear. Okay, so a conclusion from this explanation was that this simple harmonic motion is not simple. The reason is because every position पे every parameters are अलग अलग. हर एक जगह पे displacement vary करेगा, velocity is different, acceleration is different. Every position पे you would analyze. So we need some equations for that. So that's the reason why I said it is not simple harmonic motion. Means we need, is not simple, but we need some terms we need some language in terms of which we can easily understand this motion. We can easily analyze this. Alright? So before starting with that, एक differential equation है that we have to discuss, and then we'll go to and make this word very clear कि इसको simple और कैसे बना सकते हैं. So now we know that since I write Fr is proportional to minus x. That's the definition of linear simple harmonic motion. Na? Always particle is acted upon by the force which is proportional to displacement, and it is in a direction opposite to displacement. So we remove this and we write it as proportionality constant as k, and that is what I call it as spring constant or force constant. This Fr is equals to ma, which is equal to minus kx, and therefore acceleration is minus k by mx. Clear? What is acceleration? Acceleration is dv by dt. It is the rate of change of velocity, which is, मैं खाली v को लिख रहा हूँ, d by dt of v है ना. Actually ऐसा नहीं होता dv by dt, it is d by dt of v. V is the function. So what is this v here? This v is dx by dt. So this stands for what? d2x by dt2. इसको डबल डेरिवेटिव बोलते हैं डिस्प्लेसमेंट का. डिस्प्लेसमेंट का डबल डेरिवेटिव विद रिस्पेक्ट टू टाइम. तो एक्सेलरेशन इज d2x by dt2. इसको शिफ्ट करो, प्लस k by mx is equals to 0. This is called differential equation. What is this called? Differential equation of SHM. So this you remember. I will require this but not now. इसको analyze करेंगे बाद में. This is the differential equation of SHM.